Hey there, see what I do for you? It's like ridiculously early in the morning and I'm making videos for you. Okay, so this video is going to be kind of like an introduction to work and energy. And I actually looked up on Wikipedia what the definitions were, and the notes that Mr. Roscoe and Dr. Martino used are identical to the definitions that you can find on Wikipedia. So either they took the definitions from Wikipedia, or Wikipedia is not so wrong after all. But anyway, how are energy and work defined? What are energy and work? Energy is defined as the ability to do work. The ability to do W. The ability to do work. Work is defined as a transfer of energy. Kind of a circular definition, because one definition is depending on the other, and the other is depending on the first one. So, you're still kind of left without any idea as to what energy is. Hopefully I can help fix that. Basically, what energy is kind of like, say, how much energy it would take to, or how much work you have to do to push a box across the floor, say 5 meters. As you can imagine, if you have this box, right, and you're pushing it along the ground, if you just push it, if you just apply a force and let go, it's not going to keep moving. Force, or rather, work, the work that you do, or the energy that you put into something, they're actually practically interchangeable, we'll find out. Depends upon the force that you apply times the distance that you apply it for. And if you watched my one of my set the trust videos, the third, well, now it's the second set of trust videos, you should have seen that, where it's we had torque, and we multiplied the force that we were applying times times the distance from the axis. So that was the force times the distance. Hold on. So I don't know if that's really helping you much right now. I'm gonna try to give you a couple examples. Let's say we have a box on the floor. Look at a green box. And say we apply a force of 5 newtons, and so we apply that force of 5 newtons over a distance of 10 meters. 10 meters. So 5 newtons over a distance of 10 meters. So we push it 10 meters. How much work did we do? We did 50, well, think about Newton meters. Right? So force is 5. Force times distance equals work done. This is assuming constant force, obviously, but we've got a force of 5 newtons times 10 meters, and then we get 50 Newton meters. Wait, so what's that? That's actually 50 joules. That's 1 Newton meter is 1 joule, and you might see that like on like a power strip or something, telling you how much energy it can handle. That's kind of like what energy / work is. If you think about it, energy is basically how much energy you're kind of spending to push that box. Work is how much energy you're putting into that box, kind of. It's a bit of an abstract concept, remember? It's not like when the universe was created, it's not like someone, whoever, or whatever, or however it was created, it's not like there was just like some set of rules that suddenly got created. We created these rules as humans, so sometimes they don't really make sense, and this is one of those topics that doesn't really make sense. But, or at least it doesn't make intuitive sense, but it shouldn't be too difficult to grasp. For example, what happens if you push at this angle? Well, some of the force here is pushing down into the ground. And actually, one awesome thing about energy is that this entire chapter you will pay zero attention to friction, because that's an incredibly complicated topic. So all you're going to do is we're going to figure out, okay, what part of it is in this x direction, right? We're just going to do that little triangle thing. So let's say this is 7. If this is 7, well then this is what? Set, and this is, say, angle whatever. We're going to say this is angle T, and this is going to be the distance that we apply that force for. What's the horizontal piece? What's the force that we're actually applying in the x direction? Well, that's going to be 7 cosine of t, right? That's just the horizontal piece of this force, how much we're pushing along this direction, and then times the distance that it travels. So times what? However far this is, however far you push it, times d. So if we replaced 7 with just force, we end up getting that the force times the distance times the cosine of t gives us the work done. And it's kind of like two conflicting definitions, but it's really not. And it should make sense, and I'll show you why. If you're pushing on this horizontal right here, right, then all of the force is getting applied is working towards moving that block. If you're doing it at some angle, only the horizontal portion of that is actually working to move the block. And here the angle is 0, and cosine of 0, you might realize, is it's just 1. So at the angle 0, this is 1, so we just get F times D equals the work. At an angle, we just have to look at the x component of it. So we get F times D times the cosine of theta is the work. For example, oops, where'd my mouse go? So for example, just say you had this surface here, and you've got a box. You've got a box, and you push that box. Well, actually, let's say you pull that box with a force of 11 newtons, and you pull it for a distance of I don't know. Let's make it a distance of 30, I guess. We'll make it a distance of 30 meters. We got 11. Oh, and this is at an angle. It's at an angle of, we'll say, 45 degrees. Well, and this is going to be 11, the force, times the cosine of 45 times the distance, or force times the distance times the cosine. That's just what that is right there. And then we can do 45 cosine, multiply that by 30, and then multiply that by 11. And we get 233.3. So 233.3. Remember we said that Newton meters, nom, equals joules. Don't ask me why. He must have created something. Crap alarm. Sorry, I have a really loud alarm because it's hooked up to like 9 different speakers. Anyway, that's the basics of computing work, or the energy that you have to put into something to move it, or whatever. Hopefully that makes sense. Remember, this is a constant, force is being constantly applied. In my next video, I'm going to, I'll probably start on either kinetic or potential energy. Not sure which. Probably kinetic. Also, for those of you who are wondering what happened to my first set of trust videos, I don't know, some of you might have noticed that those disappeared. Someone actually pointed out a mistake to me in my videos. It wasn't a major mistake. It was a minor mistake, but it was at the very beginning, and in the math, and it actually screws up the entire answer. So, while I doubt it would really mess up any of you on like a test or anything, because it wasn't that big of a mistake. I'm still working on, I'm still going to fix it, and I'm still going to just make a whole new set of videos with stupid analogies, but it seemed to help people, so I'm going to do it. But just know it's on its way. Hope this helps. When I make either of those videos, I'll see you then.